Intrinsic semiconductors are poor conductors. They must be modified in order to possess more free electrons and holes, so it can be more conductive and be useful. How can this be done? Is by adding impurities. And the process of adding impurities is called doping. Once an intrinsic semiconductor are being doped, it will become impure and called extrinsic semiconductor. There are two types of extrinsic semiconductor. One is N-type, one is P-type. For N-type semiconductor, we add pentavalent impurities. They are atoms with 5 valency electrons. For P-type, we add trivalent impurities. They are atoms with 3 valence electrons only. Examples of pentavalent atoms are arsenic, phosphorus, bismuth, and antimony. And for trivalent impurity, examples are aluminium, boron, indium, and gallium. This diagram shows a pentavalent atom, antimony, donate a free electron. How can this be done? Now, the antimony atom forms 4 covalent bonds with the surrounding silicon atoms. In each of the covalent bonds, one of the electrons originally come from the silicon atom. The other electron come from the antimony atom. Antimony atom has 5 valence electrons. Remember that? Okay, now we count. 1, 2, 3, 4. And the 5th one becomes free electron because it cannot form any covalent bond. So we say antimony is the donor atom. It donates the free electron. In an N-type material, there are plenty of free electrons. We have discussed that just now. So electron is the majority charge carrier in an N-type material. There will be still some holes in an N-type material, but very few. They are generated thermally in the same way as those free electrons and holes generated in the intrinsic semiconductor. Since there are so few holes, the holes are called the minority charge carrier in an N-type material. This slide will explain why adding trivalent impurity will increase the number of holes in a p-type semiconductor. A boron atom is a trivalent impurity. It will form covalent bonds with the surrounding silicon atoms. There are 4 covalent bonds, but a boron atom has only 3 valence electrons. So one of the covalent bonds will lack of 1 electron and become a hole. Since the boron atom creates a hole, it is called an acceptor atom. To the opposite of the N-type material, P-type material has many holes, and the holes are the majority charge carrier. But on the other hand, it has very few free electrons, so the electrons are the minority charge carrier.